Okay, now we're going to solve a second example problem. I just want to give you guys some extra instruction here so we could go through the process one more time with a different question so you could see how the process is exactly the same as the first question, okay? So remember, before we even read the question, we're going to make a list of our 5 variables, VI, VF, T, A, and D. Remember, equal signs next to them. And now we'll go read the question before we even we'll go read the question, and we could fill in that list as we read the question, okay? So it says a car is zooming down the highway, again, at a velocity of 40 meters per second. So it's starting off the problem with a velocity in the beginning of the problem here. So we could assume that because it's starting off the problem with a velocity of 40 meters per second, that is our initial velocity, okay? And then the driver sees a deer in the road. Oh no. The driver slams on the brakes, so they're going to start slowing down and experiences an acceleration of -9. Well, if it's slowing down, yeah, it should be a negative acceleration, right? So the acceleration is -9 meters per second squared, it says. And we could fill that in for A. The car slows down and comes to a stop just in front of the deer. The car slows down and comes to a stop. That means it's not moving, right? So at the end of the problem, it stops. That means its final velocity is nothing. In this case, when it comes to a stop at the end of the problem, then the final velocity is going to be 0 when it comes to a stop and it's braking. All right, so what is the distance traveled by the car as it slows to a stop? What's the distance traveled by the car as it slows to a stop? We're going to solve for distance. Seems like time never got filled in for, though, so it's unimportant. And that's going to help us choose our equation to solve for distance. If time is unimportant, look at your list of equations. Boop, last equation right there. We're going to write that one down and use that equation. So that equation is VF, your last equation we're writing down because time was unimportant. 2 times A times D, and both velocities have a squared next to it. So let's plug in our numbers. VF is 0 squared. Then VI is 40 squared. And then plus 2 times A is -9 times D. And I'm just looking at my list and plugging in the numbers from the list. Oh, so 40 gets squared. Don't forget about that. Okay, so 0 squared is 0. Get rid of the squared. What's 40 squared? It's 40 times 40. So that is 1600 if you do it on your calculator. Then here, 2 times -9 times D. 2 times -9 is -18. And then you could keep the D. So we got rid of the squareds to start off with, and things look a bit nicer now. I don't like negatives, so if I can get rid of those, I will. I also have to get D all by itself on one side, and that's how I'll solve for it. So what I'm going to do is I'm going to add 18D to both sides. It's going to cancel on the right side, and it's going to show up on the left side of the equal sign. But remaining on the right side, even though this cancels, remaining on the right side is the 1600, right? So now it looks like this. We added 18D to both sides, canceled on the right, moved to the left. Our last step is to get D all by itself. We could divide each side by 18. So it cancels on the left, and 1600 over 18, I better do that on a calculator here. All right, I'm getting 88.88 meters. That's how far the car went while it was braking. Dang. While you're braking, you could go quite a far distance, practically a whole football field there on the highway. So it's going fast could be kind of dangerous. So the unit, don't forget to write down, is meters for distance there. There it is in your notes, okay? So remember, make your list, identify the unimportant variable to choose an equation, and then solve for the thing in your list that's a question mark, okay? Remember, if something starts at rest, if it starts at rest, VI is going to be 0. And if it ends up slowing down and coming to a rest at the end of the problem instead of the start, then VF is 0 if it stops at the end of the problem, okay? So I showed you both kind of examples where it starts at rest and where it ends at rest. Starts at rest, VI is 0. Ends at rest, VF is 0.